Okay guys, today we're going to pick up with where we left off with partial fraction decomposition. We're actually going to be doing very similar stuff to yesterday. However, now you're going to notice something a little bit different about the denominators. We're going to have a denominator that is set up kind of like this example here, where we might have a repeated factor. Right? Because this really could be factored as x plus 2 over x times x minus 1 times x minus 1. It's a repeated factor. And when we kind of solve these, if our factor is a repeated factor, we kind of have to solve them a little differently. So this is how we set these up. Now, similar to what we did yesterday, we're going to do a over x, or we're going to take the first part of the denominator and put a over x. Now, when we have a repeated denominator, this is how we have to set it up. We're going to do b over x minus 1 plus c over x minus 1 to the second power. So when we have a repeated denominator, we don't just write it out x minus 1, x minus 1. We're going to actually write it like this, where b will be over x minus 1, and c will be over x minus 1 squared. And we always do that when we have a repeated linear factor. Alright, now we go from here. Now the process of solving this is very similar to yesterday. We're going to multiply by the least common denominator. That will get rid of our denominators. Then we're going to basically create a system of equations eventually, and then solve that system. So let's go ahead and do that. The least common denominator, if you recall from yesterday, is always the original denominator. So it's always multiplying by this original denominator. Right? And in doing so, we'll get x plus 2 equals a times x minus 1 squared plus b times x minus 1. Right? Because x minus 1 cancels out one of these x minus 1s, right? And c times x. Now, what I like to do just for organization is I like to kind of like multiply all my x terms and kind of distribute my a, b, and c term last. So I would just rewrite this as a x squared minus 2x plus 1 plus b times x squared minus x plus cx. And obviously finishing up from here, distribute our a, b, and c. A plus bx squared minus bx plus cx. Now, the key to writing a system of equations is to kind of get all your x squared terms together, your x terms together, and your constants together. That way we can match them up to this left-hand side, which is always staying as x plus 2. So I'm going to rewrite this as ax squared, and this is just a commutative property, so I'm just kind of like moving these terms around. Ax squared plus bx squared minus 2ax minus bx plus cx plus a. Notice we have our x squareds together, our x terms together, and our constant. And we're going to refactor this and write it like this. A plus b plus, no more plus there, parentheses, x squared plus negative 2a minus b plus c x plus a. So we kind of do like that local factoring, that local GCF, because we're really trying to match up the coefficients of the left side and the right side together. So let's check this out. A and b, the coefficients of x squared have to match the coefficient of x squared over here. Well, what do you notice? There is no x squared. So therefore there's a 0 x squared on my left-hand side. So the first equation in my system is going to be 0 equals a plus b. My next system will be the coefficient of x has to match the coefficients of x. This coefficient is a 1. So 1 is equal to negative 2a minus b plus c. Last, my constant has to match my constant. 2 equals a. Well, right away we already got at least one answer. We know a is equal to 2. I'm going to use that to try to solve for b and c. What's nice about this example is I really don't have to go through the process of the elimination method. We will do that for the second part of the video. Now I can kind of just substitute and solve though. So I'm going to take this, substitute into that first equation. 0 equals 2 plus b. Therefore, negative 2 equals b. Now I'm going to use my equation right here, 1 equals negative 2a minus b plus c. We'll substitute our a and b terms and solve for c. 1 equals -2 times 2 minus -2 plus c. Simplifying, we get -4 plus 2 plus c, and now we can solve for here. Solving, combine my like terms, move my constants to the left, we would get 3 equals c. And that's my answer. Now, again, we really should be going back to write our answer. So I'm going to go back and rewrite my answer. I'm just going to rewrite this line, just instead of A, B, and C. Now we're going to have the answers for A, B, and C. So my final answer, which I'll distinguish, I'll write it in red, we'll have x plus 2 over x minus 1 squared. That's my original fraction. It can be decomposed into 2 over x plus -2 over x minus 1 plus 3 over x minus 1 squared. And if the check your work, I'm not requiring you guys to check your work, but if, let's say, okay, hey, do addition with rational equations or rational expressions. Well, if I added these rational expressions together, it would equal this left-hand side. Okay? Stay tuned for part 2.